Hey guys, today we are finding a counterexample. So what is a counterexample? A counterexample is an example that proves that a reasoning is false. Because sometimes we use inductive reasoning to come to a conclusion, but sometimes we can find an example that proves that our reasoning is false. So here I have some letters. The letters on the left all seem to be red, and all the letters on the right seem to be purple. So I'm going to assume, based on this pattern, that all the left letters are red and all the right letters are purple. But if I scroll down, I see that right here, the letter L is green. So my counterexample is that L is green, because that shows that my reasoning is false. So this is no longer true because L is green. So let's talk about this and look at an example that involves math. So let's say that I have this statement here, and I need to find a counterexample that proves it false. I have that x squared plus x plus 7 is a prime number. So what this statement says is no matter what number I plug in for x, the answer will always be a prime number. So this would be a great time to use a calculator. So let's pick some values. So let's try 2. Let's see if 2 will give us a counterexample. So 2, if I plug that in for x, that's 4 plus 2 plus 7. Well, 4 plus 2 is 6. 6 plus 7 is 13. Well, 13, it can only be divided by 13 and 1, because remember, a prime number can be divided by 1 and itself. All right, and 13 can only be divided by 1 and itself, so 13 is prime. Let's try 5. Okay, so this would be a great opportunity to use a calculator. So 5 squared is 25 plus 5 plus 7. Well, 25 plus 5 plus 7 is 37. 37 can only be divided by 1 in itself. And remember that a prime number can only be divided by 1 in itself. And those are the only numbers that it can be divided by evenly. So 5 is definitely not the counterexample. How about 1? Let's try 1. So I plug in 1 for x. So 1 squared is 1 plus 1 plus 7. Well, 1 plus 1 is 2. Plus 7 is 9. Is 9 prime? Can you think of any numbers that 9 can be divided by evenly besides 9 and 1? How about 3? 9 divided by 3 is 3. Therefore, 9 is not prime. A counterexample is x equals 1. Now, there are other possible counterexamples. This is just an example of one of them. All right, I'm going to pick 4. I'm going to try x equals 4. Well, I can plug that into my calculator so that x squared is 16 plus x, which is 4, plus 7. Well, if I do 16 plus 4 plus 7, well, that's 27. And I know that 27 is not prime. Remember that prime numbers can only be divided by 1 and itself. Now, 27, I could divide 27 by 3 and get 9. I could also divide 27 by 9 and get 3. Therefore, 27 is not prime. So the number 4 is our counterexample. So here I have x minus y cubed is equal to x cubed minus y cubed. And I need to find a counterexample to prove that this is not true. So I'm going to try x equals 2 and y equals 5. Let's see if that works. So that would be 2 minus 5 cubed equals 2 cubed minus 5 cubed. Well, 2 minus 5 is negative 3 cubed equals, well, 2 cubed. 2 times 2 times 2. That's 8. All right. Minus 5 cubed. That's 5 times 5 times 5. This is a great opportunity to use a calculator. So 5 times 5 times 5 is 125. We'll shrink that down a little bit, make a little bit of room. So negative 3 cubed is negative 3 times negative 3 times negative 3 equals, well, 8 minus 125 is negative 117. Well, negative 3 times negative 3 times negative 3, this is a great opportunity to use a calculator. So negative 3 times negative 3 is 9, times negative 3 is negative 27. Negative 27 and negative 117 do not equal each other. So what that means is this is a counterexample. And that's how you find a counterexample.